This class we are going to see chemistry part in general science. See, this is a very important class. In this we are going to see about three important vitamins and its chemical name. Vitamin B1, it is thiamine. Vitamin B6, it is pyridoxine. Vitamin B12, it is cobalamin. Okay. Now see, thiamine. Thiamine involved with the glucose metabolism. This is very important. Thiamine involved in glucose metabolism and maintain the nerve membrane function and synthesis of neurotransmitters. What is a neurotransmitter in the sense? See, this is the structure of nerve cell. Okay, here there are two cells. This is one and this is the next one. These two are connected with each other by means of a nerve endings. Okay, this is called as nerve terminals. They are connected each other with this. Okay, that is, for example, a message is coming and this nerve cell received through the axon, and from the message it passes to the next nerve cell. Okay, it happens between this nerve terminals. So a chemical is released at this region which will be absorbed by the nerve terminal of the next nerve. Okay, so in this way the message from one neuron passes to the next neuron. Okay, and most important thing is this is cyton, and this part is called as axon, and this is nerve terminal. Okay, now see here, vitamin B6, it is called as pyridoxine, and it is also called PLP. Okay, PLP or P5P, the name of this one. Okay, chemical name, and help to break down the proteins, carbohydrates and fats, and help breakdown of homocysteine. Homocysteine. It is an amino acid that is harmful to the body in high amounts. Okay, so it also supports healthy nerve to nerve transmission by creating neurotransmitters, the chemicals that allow nerves to communicate. Okay, so this is the main function of this pyridoxine is which one? Breakdown of homocysteine. Okay, homocysteine, breakdown of homocysteine, and also it supports the nerves. Okay, healthy nerve to nerve transmission by creating neurotransmitters. So two work it is doing. One is breakdown of homocysteine. It is an amino acid. It is very harmful to the body in high amount, so it has to break down. Okay, which has to be break down in the sense homocysteine should be break down. Okay, this is taken by this vitamin B6. B6 is doing that one. If it is more in amount in the sense it is very toxic to the body, so it has to be removed immediately. Okay, that will be breakdown by this vitamin B6. And the next important function what it is doing is nerve to nerve transmission. Okay, healthy nerve to nerve transmission. So it is creating the neurotransmitters. Neurotransmitters are nothing but chemical. Okay, see, for example, this is nerve ending and this is the next nerve ending. In the sense it release the chemical. This nerve release the chemical. Okay, comes to this one. Okay, the chemical. Okay, so like this this chemical part enters into the axon of the next neuron. Okay, so this is how the message will transmit from one neuron to another neuron through the neurotransmitters. Okay, this is done by B6. Okay, next one, see, B12, cobalamin. Okay, in addition to helping the main function of this one is form healthy red blood cells. This is the first function. Okay, what is the first function? Helps to form healthy red blood cells. Next function is main thing. It helps develop brain and nerve cells. Okay, brain and nerve cells are developing because of the presence of vitamin B12. It is cobalamin. Okay, cobalamin it is. Okay, especially it helps build and maintain the myelin sheath surrounding the And the next, how it is maintaining, in the sense it helps to build, as well as third function, see, the myelin sheath surrounding and protecting the nerves. Okay, it maintain the myelin sheath. Myelin sheath means, see, what you're seeing here is the myelin sheath. Okay, myelin sheath. Inside that there will be an axon. Okay, axon is a long long part of the nerve cell. Okay, this is axon, just like electric wire, and plastic covering around the electric wire na, that is this myelin sheath. Okay, what you are seeing here na, this is the myelin sheath. So this cobalamin is very important for the production of this one. Okay, it maintains the myelin sheath, because this myelin sheath are very important. So the leakage of the electric charge will be controlled by this myelin sheath. Okay, next one. Catenation is the self-linking atom of an element to create chains and rings, the capacity to create double bonds, the ability to form different types of double bonds, and the configuration of the element's molecular orbits surrounding the atom are all electronic and steric factors that affect catenation. Okay, so the element shows maximum catenation is carbon. So you might understand, catenation is the self-linking of atom of an element to create chains or rings. See, for example, C. Okay, C H. Okay, it connects with CH4 in the sense CH4 in the sense C. So this carbon atom is connected with 4 hydrogen atom. Okay, 4 hydrogen atom. So CH4, okay, or NH4. Okay, so like this, the connection is called as catenation. This connection is called as catenation. Okay, next one, see. One of the group of metal in the center of the periodic table. Transition metals are heavy, they melt only at high temperatures. They form colored compounds. They can combine with another element to form more than one compound. And they often act as a catalyst. Okay, example is copper. One group of the metal in the center of the periodic table. Okay, a group of metal in the center of the periodic table, those metals are called as transition metal. Okay, center of the periodic table are called transition metals. Okay, they are heavy, they melt only at high temperature. They are very heavy and melt only at high temperature. Okay, they form colored compounds. They can combine with another element also to form more than one compound, and often they act as a catalyst. Which one? The transition metals. Example copper. Okay, copper is one of the example. Next one, see petroleum. How petroleum is forming? Let us see. Petroleum is formed from dead organic matter. When a large amount of dead organism, usually zooplankton and algae, are buried underneath sedimentary rock and subjected to intense heat and pressure. After such a process, the molecule turn into petroleum. Zooplankton is organism found in ocean and seas. See, you can find here how the petroleum is forming, in the sense petroleum forms in the, that is under the ocean. Okay, ocean, that is oceanic organisms. They are sedimented inside the sands and they form the petroleum. Okay, so very important point you have to keep in mind is petroleum is formed from dead organic matter when a large amount of dead organism, usually zooplankton and algae, are buried underneath sedimentary rocks and subjected to intense heat and pressure after a process. Okay, after process, the molecule turn into petroleum. Okay, so zooplankton is organism found in ocean and seas. Okay, all these organisms are buried inside the rocks. Okay, inside the rocks, that is sedimentary rocks, and from there we are getting the petroleum. So where we are getting the petroleum, in the sense in the ocean, okay, in the ocean and the seas we are getting the petroleum. Okay, petroleum where we are getting in the ocean or seas. Okay, from the ocean or seas we are getting the petroleum. Keep in mind. Next one, see, what is the oxidation state of hydrogen in LiAlH4? Okay, this chemical, the oxidation of hydrogen is -1. Okay, the aprotic solvent is HF. Okay, hydrofluoric acid. Aprotic solvent is. These are all very important questions in TNPSC. So carefully note it. Alluvial soil have generally low mineral content of dash dash and dash. Okay, so what are those? Nitrogen, phosphorus, potash. So in alluvial soil these chemicals won't be there. Okay, won't be there, or in very less amount. Okay, which chemical? What are those chemicals? Nitrogen, phosphorus and potash. Okay, then come to the next one. Superheated gaseous states are known as plasma state. Okay, if we heat the gas in a high temperature, in the sense they come to a state that is called as plasma state. Okay, that's called as plasma state. And next one, Bose Einstein condense is. What is Bose Einstein condense means? It is supercooled solids. Absolute, it is between absolute 0 degree to minus 273 degree. Okay, what is that called? Bose Einstein condense. This is also very important question in TNPSC. Okay, so what is that? Supercooled solids. Okay, its degree is between 0 to minus 273. Okay, mass of electron. What is the mass of electron? 9.1 into 10 raised to minus 28. Okay, minus 28 mass of electron. So very light. Okay, mass of proton 1.6 into 10 raised to minus 24. Mass of neutron 1.6 into 10 raised to minus 24. Okay, if we take an atom, atom has a nucleus and it is surrounded by the rings. Okay, where the electrons will be. Okay, and inside this nucleus proton and neutron will be. Okay, protons and neutrons. This is electron. It is negatively charged. Okay, negatively charged it is, and this proton is positively charged. Okay, so P positive, just keep in mind, positively charged. And what about neutron? There is no charge. Okay, no charge. So these two, what we call, this mass of proton and mass of neutron are equal. Okay, and the mass of electron is light, very light. It is 9.1 into 10 raised to minus 28. Okay, let us see monotonic. What is monotonic? A molecule of an element which has the atomicity 1 or having only one atom in its molecule is called as monoatomic. Okay, monatomic are basically noble gases, which means they can exit freely without reacting with any other substances. Example, organic helium, neon are monoatomic, all noble gases. So see, monoatomic in the sense only one atom will be there. Okay, AU, okay, like that. Okay, single atom. So it is called as mono, single atom. Whereas if you take H2O, okay, H2O, this is polyatomic in the sense H2O, isn't it? H2O. So one O and two hydrogen. This is water, right? Chemical formula for water is H2O. Now see here, this is O is single and two two hydrogen atoms are attached with this. Okay, so this is water molecule is polyatomic. Polyatomic. Okay, monatomic in the sense single atom, that is called as monoatomic. Okay, monatomic. Now see here, polyatomic ion is an ion composed of more than one atom. The ammonium ion consists of one nitrogen atom and four hydrogen atom. See, NH4, isn't it? So N, H, one H, second one, third one, and fourth one. Okay, so this is known as ammonia. Okay, and NH4. So this is polyatomic. This is one atom, this is another atom, and this is one. Okay, five atoms are here. So it is polyatomic. Okay. Next one, see difference between the molecules and atom. Okay, atom. What is atom? What is molecule? We have to know. Okay, atom is the smallest particle of the element. Element means what? You all know what is element, isn't it? Element in the sense it is, see, I told you in the last AU, okay, AU and hydrogen, okay, hydrogen. So all those elements are very smallest particle of an element is known as atom. Smallest particle of an element is known as atom. Okay. So molecule means molecule is the smallest particle of an element or compound. Smallest particle of an element or compound. Okay. Atom does not exist in free state except in a noble gas. It does not exist free. Okay. Atom never exists free. Immediately they wants to join or combine with because the outer region there will be electrons, no, it always wants to join with some other. Okay, so these electrons are very active. The outermost one are very active, they want to join. See, for example, if it is oxygen, let us take oxygen, the outer electrons will be very active to join with hydrogen. Okay, hydrogen, now it is H2O, it forms. Okay, so in molecules, okay, if you take the atom does not exist in free state except in a noble gas. Okay, molecule exists in a free state. Molecules in the sense, say for example, this is water molecule, they will be free. Okay, they will be stable. Why? In the sense that this is full molecule, so water molecule is stable, whereas the oxygen is always have the capacity or capability to combine with the hydrogen. When it starts attracting the hydrogen in the sense electrons, okay, two electrons, they come and join with this outermost electron and they form a molecule. Okay, so this one, except some noble gas, other atoms are highly reactive. Okay, highly reactive, they are atoms are highly reactive, whereas in molecule they are less reactive. I told you now. See, this oxygen, this outermost part is very active. These electrons are very active, whereas here in water molecules it is saturation level, this outer ring is, so they won't react with the other molecule. Okay, so they will be stable, they will be inactive. Okay, now atoms does not have a chemical bond. Atom does not have a chemical bond. Okay, there won't be any chemical bond. See, O, if you take O will be that. AU in the sense they won't have the chemical bond. Whereas atoms in the molecule are held by chemical bonds, like this one. Okay, this is atom, but this is molecule. They are interconnected with a chemical bond. Okay. Next one, Avogadro's law. What is Avogadro's law? Let us see what is Avogadro's law. Avogadro's law states that equal volumes of all gases, listen carefully, equal volumes of all gases at the same temperature and pressure, they have the same number of molecules. Okay, okay, what is that? What is that? Same, that is equal volumes of all gases. Let us take the volume of all gases. See here oxygen, here hydrogen, and here nitrogen. Let us take. Okay, let us take, this is oxygen, Okay, this is oxygen. This is same the amount of gas. Okay, this is oxygen, this is nitrogen, and this is, let us take hydrogen. Okay, let us assume that equal volume. These three are in equal volume. Oxygen, okay, oxygen, nitrogen, and hydrogen. Okay, in equal volume. What is the Avogadro's law? Equal volumes of all gases at the same temperature and same pressure. Okay, they have the same number of molecules. Okay, if the temperature and pressure is same, they have same number of molecules. For example, here it is 7 molecule in the sense 7 molecule. Okay, 7 in the sense here also it will be 7. The number of molecules are same. Okay, number of molecules are same in all the three gases. All the three gases, it is same. Okay, now sorry, this is yes, 7. The molecule number is 7 here. Here also it is 7. Here also it is 7. This is Avogadro's law. Okay, so what is Avogadro's law? Avogadro's law, that is equal volumes of all gases. See, you just imagine the volume is same. Okay, same equal amount of volume, where the temperature as well as pressure is same in the sense, then the number of molecules, okay, not mass, number of molecules are same. Okay, so here see, V1 by N1 is equal to V2 by N2. When the temperature and pressure are constant, this equation is used to compare different conditions on the same substance. Okay, now volume is directly proportional to the amount of gas in moles. V by N is equal to K. Volume divided by the amount of gas equals to K. Okay, it is constant. It is constant. Okay, so this is called as Avogadro's law. This one you have to keep very important. You keep in mind this one. Okay, equal volumes of all gases at the same temperature and pressure, they have same number of molecules. Okay, now see, lead is still widely used for car batteries, pigments, ammunition, cable sheathing, and weights for lifting, weight belts for diving, lead crystal glass, radiation protection, and in some soldiers. Okay, soldiers. It is often used to store corrosive liquids. Lead also used in X-ray machines. Okay, so this is use of the chemical. What is that metal? Lead. Okay, where they are used in the sense X-ray machine. Sometimes the question may arise. Okay, lead in X-ray machine. What we are using is lead. Okay, lead, and also it is widely used for the car batteries, pigments, ammunition, cable sheathing. Okay, cable sheathing. Cable, inside the cable you can find the lead. Okay, and weights for lifting, weight belts for diving, lead crystal glasses they have the lead. Okay, and radiation protection, and solder in the sense for welding the very minute radio parts or some other parts. If you solder it, for soldering we use this lead. Okay, and main important thing is in X-ray machines we are using lead metal. Okay, next one, see, dash is used as rocket fuel. It is hydrogen. Okay, dash flame is used to cut and weld metals. It is hydrogen. Okay, hydrogen flame. Okay, see, this is what called periodic table. In periodic table, you can find, see, these are called as the transition metals. Transition metals, okay, which are very, very hard metals. Okay, transition metals. And then, see, you have to see this block is called as S block. Okay, S block. And this block is called as F block. F block. Okay, and this block is called as P block. So how many blocks are there? This block is called as D block. There are major 4 blocks: D blocks, okay, S block, and this is F block, and this is P block. Okay, P block. And these are the non-metals which are in yellow color. These are non-metals. So where the non-metals come in which block, in the sense you might have able to say it is P block. Okay, non-metals are coming in P block. Okay, P block. Okay, and rare earthen elements. These are called as rare earth elements. Rare earth elements. Okay, they are come in F block. F block. Okay, and actinoid. These are called as actinoid. They are also coming in F block. So actinoid and rare earth elements are coming in F block. Okay, and S block. What are coming in S block? These are alkaline earth metals. Alkaline earth metals are coming in S block, and these are alkali metals. Alkali metals. Okay, alkali metals. You can say these two alkaline. Okay, are coming under S block. S block. And D block. D block. What is coming in D block? Transition metal. Already in the first question we have seen. Okay, D block. D block. These all are called transition metals. These are coming in D block. Okay, so transition are in D block, and this is alkaline are in S block. Alkaline are in S block, and rare earth element and actinoid. Actinoid. Okay, earth element and actinoid are coming under F block, and all these are non-metals. Okay, all these are non-metals. The yellow color. Okay, non-metals are coming under P block, and these are metalloids. Okay, metalloids are also coming under P block. Okay, and this is noble gas. Noble gas. How many are there? 1, 2, 3, 4, 5, 6 noble gas are there. This is also coming under P block. Okay, okay, and this one it is post transition metal. Post transition metal. Okay, so few are coming in D block and few are in P block. Okay, see, how was the atomic number discovered? Henry Moseley made the discovery of the atomic number in 1913 while analyzing the X-ray spectra. Okay, so this point is very important. Keep in mind, Henry Moseley, he made the discovery of the atomic number in 1913 while analyzing the X-ray spectra. Okay, he discovered that when we increase the atomic number, by 1, certain lines in the X-ray spectra of atoms move by the same amount of each time. So by this way he found out this one. Which one? Atomic number. Atomic number, because they are, when we increase one number by 1, certain lines in the X-ray spectra atoms move by the same amount each time. Okay, so from that he found out this one. Which one? The atomic number he found out in the year 1913. Who found out? Henry Moseley. Okay, in which element? X-ray. Okay, X-ray spectra. He found an X-ray spectra. Next one, see. How many metals and non-metals are there in 118 elements? Okay, see, 100 elements are there in the periodic table. This is very, very important question. So how many elements are there? It is 118 different elements are there in the current periodic table. Okay, and among this 18 are non-metal. 18 are non-metal, 7 are metalloid, and 93 are different types of metal. Okay, so keep in mind, how many? 18 are non-metal, 7 are metalloid, 93 are different types of metal. Okay, the creator of the periodic table is Dmitri Mendeleev. Okay, in 1869. In 1869. Okay, the periodic table was created by Dmitri Mendeleev. Okay, Mendeleev in 1869. Thanks for subscribing and sharing to your friends. Okay, share this video to your friends, those who are preparing for the competitive exams, and thanks for watching and sharing this. Thanks for subscribing and sharing to your friends. Okay, share this video to your friends, those who are preparing for the competitive exams, and thanks for watching and sharing this. Thanks for subscribing and sharing to your friends. Okay, share this video to your friends, those who are preparing for the competitive exams, and thanks for watching and sharing this.